This one is the SI quantity and the graph interpretation POPCO is 2. A tennis ball is moving through the air. The diagram shows the horizontal and the vertical components. Which of the following expression give the magnitude of the velocity? So it's horizontal and the vertical components are there, parts are there. And what we need the magnitude of the velocity for this. So we have a right angle triangle here. And we need this velocity, like this is unknown. And all the options are given in trigonometric ratios. So with reference to the angle, because like this one is a hypotenuse, so the angle is always between the hypotenuse and the base. So this one is a base. And opposite to the base is perpendicular. So this one is a perpendicular. So if we write the trigonometric ratios, like if we write sine theta, it is perpendicular over hypotenuse. If we write cosine theta, it is base over hypotenuse. And if we write tangent theta, it is perpendicular divided by base. So because the sine is used here, all the options we have sine, so means we don't have to use these two. So we just substitute the value. So the sine theta, what is the sine theta? Sine theta is perpendicular divided by hypotenuse. So what is the perpendicular for us? The perpendicular is 5.5. And what about the hypotenuse? That is what we are finding. Like that is unknown to us. You can say V, you can say X, any variable can be used. So if we need the X and theta, what about the theta or the angle here? The angle is 22.6. So in place of theta, we can substitute as 22.6 degrees. So if we need X, so X will be equals to 5.5 divided by sine 22.6. So 5.5 divided by sine 22.6. So it matches with option C. So C will be the right answer. We can use cosine theta or tangent theta, but in the question, because the option does not include any cosine or tan, that's why we directly use the sine. Which of the following is a scalar quantity? Weight is a vector quantity, momentum has direction vector, velocity is a vector. Energy, any kind of energy, chemical, kinetic, potential, all these energies are scalar quantities. Which of the following is a vector quantity? Density is a scalar, all kind of energy, scalar. Viscosity is also scalar. The momentum has a direction, so momentum is a vector quantity. Two forces P and Q act on an object. There are two ways to get the resultant. You can use either a parallelogram method or you can use a triangle method. If you're using a parallelogram method, the two vectors must start from the same point and we complete a parallelogram and the diagonal will be the resultant. If you use a triangle method, you draw the first, any one of the vector, then the second vector, and from tail of the first to the head of the last, that will be the resultant. So two of the options are triangle methods, two of the options are parallelogram methods. So if this parallelogram, then what should be the resultant? Resultant should be in this direction, but the direction is not correct. If it is a triangle method, we draw the first vector, then the second vector. So the tail of the first to the head of the last, that should be the resultant. So the direction of the resultant is not correct in B. Here, what is the mistake here? The resultant is a diagonal of the two vectors, starting points of the two vector, but this is the other side it is starting, so that's why it is not correct. So we are left with option D. Which of the following quantities has a SI base kilogram meter square second minus 3? So when we talk about force, force is Newton. Newton is like F is equals to ma, any formula you can use. Mass is kilogram and acceleration is meter per second square. So this will become kilogram meter second raised to power minus 2. So it does not match, so it cannot be force. Momentum, the product of mass and velocity. So mass is kg and the velocity is meter per second. So it will become kilogram meter second raised to power minus 1. So that's also not correct. Power, power is work divided by time, or force into distance divided by time. Force is Newton, or the base unit is kilogram meter second minus 2. Distance is meter and the time is second. So first when we simplify, this will become kilogram meter square second minus 2 divided by second. And then second minus 2 divided by second. So this will become second minus 3. Because when we move the denominator to the numerator, the power will change. So it is 1 here, it will become minus 1. Minus 2 is already there and minus 1. So this will become minus 3. So kilogram meter square second raised to power minus 3. That's why C is the right answer. What about the work, which is a product of force and distance? So unit of force is kilogram meter second power minus 2. And the unit of distance is meter. So it will be kilogram meter square second minus 2. Quantities in physics are classified as either vectors or scalar. Which of the following unit could only be used for a scalar quantity? So first one is meter per second. Meter per second can be the unit for speed. It can be the unit for velocity as well. So velocity and speed. Acceleration, meter per second square is acceleration, and acceleration is only for vector. Kilogram meter per second square, that is the force, as you can see, which is equivalent to Newton of force. But kilogram per meter cube, that is density, and density is the unit for scalar quantity, not for vector quantity. So D will be the right answer. The student walked 12 kilometers on a bearing of a 135 degrees, then walked 20 kilometers on the bearing of 340 degrees, as shown. Which of the following could represent the final displacement? So we just have to add the vectors. Any one of them you can start with. Like example, if we start with 12 first, and then 120, because we draw the first vector, then we draw the second vector. And what about the resultant? Resultant is always from tail of the first to the head of the last will be the resultant. And as they mentioned, the diagram is to the scale, means you have to use a measurement of the diagram. Like example, if this is 3 centimeter, you will use your scale, a ruler, and measure the length. Example, this is 3 centimeter. Use this and scale accordingly. Like example, this is 5 centimeter. So you have to draw according to the scales. You cannot just draw the rough diagram. So you have to draw according to the scale, like first 3 centimeter at an angle of 135 from the bearing, that means north, and then 340 the clockwise from north, or 60 you can also say from vertical. You draw like 5 centimeter, and then to get the resultant, it will be from tail of the first, like the first vector, join the head of the last. That will be the resultant. So A, B, C, or D, like we have different options are there. When you draw, you will work out, like you will identify that when you complete the diagram, it will be somewhat like this. First vector will be the 12-kilometer vector and then 20-kilometer vector. So what will the resultant? Resultant is from tail of the first to the head of the last. That will be the resultant. So when we check the options, it matches with B. So B will be the right answer for this. And as they mentioned, diagram is to the scale, so you have to use a measurement from the diagram. The unit of the power is what? What is equivalent to? So we just did now, power is equals to force into distance divided by time or work. Unit of the force is kilogram, meter, second minus 2, unit of distance is meter, and unit of time is second. So this will move in the numerator. This will be kilogram, meter square, second minus 3. So it matches with option D. Measured quantities can either be scalar or a vector. Select a row from the table, which is not correct. 21 degrees, which is a temperature. The temperature is a scalar quantity because it does not have a direction. Time, this is a time, so time is a scalar. This is meter per second square, so which is acceleration, it's a vector. Joules, energy or work, it is not a vector, it is a scalar quantity. Which of the following quantities could have the unit Newton, meter, second minus 1? So when we talk about the power, because power is force into distance divided by time. Unit of the force is Newton, unit of distance is meter, and unit of time is second. This will move. So this will become Newton, meter, second minus 1. So C will be the right answer. This is a gravitational potential energy, and unit will be Newton, joules or Newton meter. Gravitational field strength, it will be Newton per kilogram. Work done, it will also be Newton meter or joules. Joules is equivalent to Newton meter. So in any form of energy, you can use joules or Newton meter. It's the same thing. Question 11, the equation for work done is force into distance can be used to calculate each quantity. So what about the work done? Work done is a scalar quantity. What about the force? Vector, and this is a displacement here, which is also a vector. If it was a distance, then it is a scalar, but work done is a product of force and displacement, because we always consider the distance from the starting point or the shortest distance between the initial and the final position. So S here is a displacement, not the distance. The diagram represents the two forces acting. Which of the following shows a correct way of finding a resultant? So if you want to find the resultant, two ways are there. A parallelogram method. If you use a parallelogram method, then the diagonal will be the resultant. If you use a triangle method, we draw the first vector, then we draw the second vector. From tail of the first to the head of the last, that will be the resultant. So this is wrong because the diagonal should be the resultant. This is also wrong because the diagonal should be the resultant. This one, the direction of the resultant is not correct, because like if this is the first vector and second vector, the direction of the resultant from tail of the first to the head of the last. Here it is correct, the first vector, the second vector, and the resultant vector. That's why D is the right answer for this. So this was a pop quiz 2, which was related to SI quantities, unit, and graph.